Hello, James. How are you?
Doing well. How are you, Panna?
I'm good. I'm good. It's great to chat about such an important topic, protein, because many people restrict their protein these days. Many people increase their protein. So I would like your opinion on everything around protein. Are you ready
Sure.
to start?
Yeah, let's do it.
Good. So just as an introduction and just to set the right foundation, why is protein important in your opinion?
Well, in order for us to create hormones, et cetera, we have to have a certain amount of protein intake. And also, eating adequate amounts of protein has been shown in numerous studies to lead to better weight loss because it's very satiating. Because about 30% of the caloric intake goes into the thermic effect, which is like basically the amount of calories that it takes to simply burn protein. And so basically it's just good. It's good for weight loss. It's good for muscle building, etc. So I think a lot of people aren't getting in sort of like the lay public aren't getting enough protein. And then people that are sort of more in the carnivore space, they might be getting too much protein. And
Mhm.
so protein needs, just like kind of carbohydrate needs, also need to be adjusted based on your muscle mass, based on your activity level, based on your resistance training, etc. So there could be someone that isn't overeating protein per se, but they're not lifting weights, they're not moving much, and they're actually overeating protein compared to someone that's actually lifting weights and has a higher muscle mass. Even though that person is eating much, um, you know, for the same amount of protein, let's say, because they're moving less, their protein they've overshot how much they need. So basically, just like kind of like carbs, protein does need to match activity level, muscle mass, etc.
Okay. So, from your perspective, protein is mostly for structure, right? Let's say if someone goes 1 gram per kilo or 2 grams per kilo, he would primarily want or to use this protein for structure.
Yeah, so essentially, like in order to remain, let's say, in positive like amino acid balance, the old studies looking at nitrogen balance sort of underestimated our needs because it's not, there's several flaws in looking at nitrogen balance. So that's what the RDA is based on. The RDA has set its standards at zero point 0.8 grams of protein per kilogram body weight based on nitrogen balance studies. But looking at stable isotope studies and phenylalanine oxidation, which are kind of better methods, it seems like 1 to 1.2 is actually more accurate in regards to metabolism, structure, function, hormone production, etc. And then for optimal muscle protein synthesis, that will depend on, if you're doing a total body workout that day or not, but somewhere between 1.6 and 2.2 grams per kilogram is going to give someone more of an optimal muscle protein synthesis. But that doesn't mean that just because that amount is optimal for muscle protein synthesis, that there aren't harms going above 1.2,
Mhm.
right? Like, so there's benefits to doing that, but there's also some potential harms that you can offset. But essentially, the more particularly animal protein you consume, the greater amount of hydrogen ions that get released by the liver. So the larger acid load and the more acidic that the body becomes for those 4 hours that after you consume animal protein. So when you consume animal protein, it's about 2 to 5 times higher in sulfur containing amino acids like cysteine and methionine compared to plant proteins. Why does that matter? Because when the liver oxidizes cysteine, and methionine gets transferred and converted to cysteine in the liver. So when you eat methionine or cysteine, the liver oxidizes that to sulfuric acid. And that dissociates to a -2 sulfate and 2 hydrogen ions. So you are pushing hydrogen ions out of the liver when you consume animal protein. That will deplete your bicarbonate. Okay. And the remaining, so basically your bicarb will kind of handle about 70 or 80% of the release. And then the rest will circulate and go into the capillaries and acidify the interstitial fluid and that will activate osteoclasts to start breaking down bone. And so we know this from numerous metabolic ward studies. So the Bellevue study was a 1-year carnivore study. It was a 4-month metabolic ward study, but a 12-month follow-up with calcium balances out to 12 months. And Stephenson and Anderson, it put them in negative calcium balance, significant negative calcium balance for the entire period. And so even at the end of those 12 months, Stephenson and Anderson were losing about 175 milligrams of calcium out the body every single day. Now, from my knowledge in researching for 15 years, if the body is losing an essential mineral and it has the ability to prevent it, it will prevent it very quickly. So when you go on a low carb ketogenic diet, you start spilling sodium, but the body starts ramping up a positively charged ion called ammonium to offset the sodium loss. So within a week, the big sodium loss that has happened on a low carb diet, your body compensates for. So it goes down very dramatically because it's trying to preserve an essential mineral. We know from balance studies with the Bellevue study, the body still can't even compensate for this calcium loss out to an entire year. So in my opinion, if the body is not able to do that within a year, it really should be able to do that within a couple of weeks. But if it can't do it within a year, it's very unlikely that it's somehow going to randomly decide to compensate after a year. So the one harm of overeating or just eating, let's say, muscle meat carnivore without good amounts of dairy, and you're going to need about at least 500 milligrams of calcium to remain in balance on a carnivore diet, you will be in negative calcium balance. Eventually, that could lead to such a significant loss of calcium from the bone that there could be harms on bone. We don't know because we only have 1 year of study, but you can do the math and you can extrapolate out. We have 1.2 million milligrams of calcium in our bone. It probably will slowly go down, but because within like the first couple days, Stephenson and Anderson were losing like 300 to 500 milligrams every day. So it did decrease over the year. It went from like 500 milligrams lost out of the body down to about 175. And so that could potentially keep trending down. But if you do the math, you do 100 milligrams, let's say, is lost every day from bone, in 10 to 20 years, that could be a 20 to 40% loss of calcium, which could be picked up on a bone mineral density scan. So it's not like this will happen very quickly, but it can, if that continues, then you could see what the problem could be.
But you brought up an important point, and I think we need to kind of like pin it. So we may want 1 to 1.2 grams per kilogram. Ideally, we can go for muscle protein synthesis a lot higher, but that's not ideal. So, and even people then or athletes, for example, and might consume 2 grams of kilogram, then they still will get some, if not all, of the, let's say, problems or issues with a high protein diet, right? So being an athlete doesn't offset or maybe it does. That's
Yeah, so it will. So basically, being an athlete, lifting weights, having more muscle mass will push more methionine into the muscle versus more methionine being converted to cysteine in the liver and oxidizing to hydrogen ions. And it will also push more cysteine to forming glutathione from all the oxidative stress that you created exercising. So yes, building muscle, resistance training will push more amino acids away from oxidizing in the liver and forming hydrogen ions and making the body acidic, and more into muscle and more into forming glutathione. So it does offset it some, not fully, but it will offset it somewhat. But again, you're going to be craving more protein and eating more protein anyway, because people who lift weights typically end up eating an extra meal because of that weightlifting session to get another 40 grams of protein. I mean, even myself on resistance training days, if I lift weights pretty hard, I typically end up eating 4 times a day versus 3. So it's kind of not really offsetting because you end up eating more protein anyway. But I think it's actually optimal to eat a little bit higher of a protein intake and just offset the acid load with bicarbonate, because we used to get bicarbonate from fresh meat and fresh fluids. It wouldn't fully offset the acid load, but basically nature provided us with bicarbonate. We never would have consumed meat within 6 hours that didn't have bicarbonate in it, because bicarbonate is about 10 millimoles per liter in the cell, and there's about 1,000 milligrams of bicarb in fresh muscle and about 1,800 milligrams per liter of extracellular fluid. Plus, we could have gotten a lot of bicarbonate forming substances through gnawing on bone or eating bones,
Hmm.
like fish bones, etc. Because there's a lot of carbonate in the bone and citrate, both of which can form bicarbonate in the body when you consume it. And also, natural waters contain bicarbonate. And then also, we need to understand too that we didn't leave Africa in a significant, meaningful way until 60,000 years ago. And Denise Minger has a very good article on all the actual wild, large fruits naturally growing wildly in Africa that have high amounts of sugar. So we would have had access to carbohydrates as well, but also bicarbonate by eating fruits and tubers too, which you could just kind of pull from the ground in Africa. So in other words, like we used to get bicarbonate, a modern day carnivore diet does not provide that anymore. The grocery store meat no longer has any bicarbonate because it's not fresh. And if you're on a carnivore diet, you are not consuming fruits and vegetables. So getting the high protein is good, in my opinion, for muscle protein synthesis from a weight loss perspective, but it comes with the acid load. So if you can just offset the acid load with bicarbonate or citrate, then you're getting the benefits of the high protein, but you're offsetting the acidosis. Now, you still have to deal with the increased um, urea and the increased uric acid from purine intake, and you are still going to be hyperfiltering quite a bit to get rid of all that urea. But the bicarbonate will offset the hyperfiltration by about 20 to 30%. So what happens, here's the other potential issue with high protein intakes is if you have good kidney function, so they've done studies in young men like early 20s. When they eat a high protein load, they have such good kidney function and what's called renal reserve that they can really hyperfilter extremely well. Their GFR goes up by 50 to 100%, and they hyperfilter to remove all that urea and acid. The problem is that massive hyperfiltration was shown to over double the albumin in the urine. So when you are pushing out more albumin in the urine, technically that is likely due to kidney damage. So if you're able to hyperfilter and you're younger and you're consuming a lot of whey protein powders or casein protein powders plus a very high animal protein diet, and you're constantly hyperfiltering, that could potentially lead to increase in albumin, which has been shown in many studies. That could lead to potential kidney damage. And then all of a sudden your GFR starts to decline. So what typically happens is GFR goes up at first and you go, oh, my GFR, my kidney function is so good. Well, if it's hyperfiltering and causing albumin to spill out in the urine and you're damaging the kidneys and you do that over, let's say, a decade, then your GFR will start to decline. So there's possible, I'm not going to say proven, that in younger individuals that are consuming high animal protein diets, whether it's from supplements or not, there will be a potential doubling or more of albumin in the urine. There will potentially be damage to the kidneys. We just don't know if that leads to kidney damage in the long run.
Okay, super interesting. And ties with what I had in mind to ask you right now, which is uh, BUN and urea, and you mentioned it. Because urea, to my understanding, is kind of an indication that you're using protein because of the metabolic pathway it follows as energy, right? So you're not converting it, and the extra ammonia, which is going through the urea cycle, actually means you're using it for energy. So is an increased BUN an indication that you're not necessarily eating too much protein, but maybe you're not eating enough calories, and at the end, that percentage of protein you're using is being used for energy and not for structure for your muscles, etc.
Yeah, so
Just as an example, I've seen it in a couple of people I've worked with, where they moved from a, let's say, normal diet to a more carnivore-ish diet or close to, and their BUN increased, their triglycerides increased, doubled, which for me indicates that they were not able to, or that they were not able to use the protein for muscle protein synthesis, but they were actually using it for energy.
yeah, so I would say in general, yes. Let me do a few caveats and then let's also dive into a little bit. So,
Okay.
so if you rule out dehydration, which can increase blood urea nitrogen, and you rule out certain medications which can increase BUN, like corticosteroids, some antibiotics, diuretics by causing diuresis and dehydration. So you rule out those things, then yes. So what ends up happening is when you consume more amino acids than you need, 60 to 70% of those extra is going to go towards urea, the urea cycle. 20 to 30 will go towards like gluconeogenesis, depending on carbohydrate intake. And then depending on if you're in a calorie surplus, 5 or 10% of the extra will go towards like fat storing.
Mhm.
So you're correct. As BUN increases, what's happening is that is from amino acids that aren't being used for structure function effects. So um, one thing that happens is first, when it's happening in the liver, you're deaminating the proteins. You're removing an amino group, right, from the amino acids, which is NH2. That converts to ammonia, which is toxic, NH3.
Yep.
NH3 will then combine with bicarbonate, and eventually you'll form like arginine and then citrulline and then urea. So essentially, that process too is actually depleting bicarbonate, which that is increasing the acid load of the body as well through the urea cycle. So yeah, your urea is basically a waste product from amino acids that you have overconsumed. So
Okay.
when BUN is high, you are consuming more protein than you need if you've ruled out certain things like dehydration and medications. Yeah.
I think that's important to highlight to everyone listening to this because I mean I see a lot of blood work, and if I'm honest, I 90% maybe even is uh, people who are above BUN of 30. And typically the recommendation, and you can correct me if I'm wrong, it's around 20, right? 18, 20 or so. And even ladies typically have a bit lower, so maybe 25, 27. But in my take, either people are eating less and they're relying a lot on protein, or they're overeating protein.
Mhm.
Probably the first, the former, i.e. they're not eating enough calories, and they're relying more on, let's say, chicken and salad. So, which is
Mhm.
a good weight loss strategy, but not in that context, and we'll discuss a bit more. Maybe not, it's not the best for your kidneys or for your liver, etc., right?
Right. Yeah. So, well, we need more data on if the enhanced ammonia that's being produced in the liver is causing potential damage. And same thing with the kidneys, because the kidneys have to produce more ammonia as well when the liver releases more hydrogen ions. And we can get into the weeds on how that works. Um, but the other thing is there's a few things. So carnivores will say, okay, how do I know if I have low grade metabolic acidosis?
Hmm.
Most carnivores that I've looked at actually have clinically low bicarbonate. So if you look at their CO2 level, usually it's like 23. You just multiply CO2 by 95%. That's what bicarbonate is. Bicarbonate makes up 90 to 95% of CO2. I like to go with 95%. That's erring on the, better side of caution anyway. And so you're not like overestimating a really low bicarb. It's a good indication. So if you have a 23 CO2, a lot of people go, "Oh, look, I'm in the normal range." But the normal range for CO2 is wrong. Anyone who understands how much bicarbonate makes up CO2 will understand this because the normal range for bicarbonate is if you're less than 22 bicarb, you're clinically low. Some labs will even say if you're less than 23 millimoles or milliequivalents per liter, you're clinically low. But let's just go with the lower end at 22. If bicarb is 95% of CO2, just look at your carnivore CO2 level, multiply it by 95%, 0.95, and 23 CO2 is less than 22 bicarb. That is clinically low bicarbonate. I can't tell you how many people I've seen with carnivore, and Paul Saladino gave me the okay to mention him in his labs. He sent me his labs a long time ago when he was on carnivore. His CO2 was 23, so he had clinically low bicarbonate. Carnivore JT did a video trying to blast me. Look at my labs, I'm fine. He also had a CO2 of 23, which I thought was a little laughable because he kind of just proved that he has clinically low bicarbonate. So most carnivores don't understand this because the normal range for CO2 is incorrect because the normal range for CO2 is like 22 to 30, which makes no sense because if you're at 22, you're already borderline low on bicarbonate, and CO2 is made up of more than just bicarbonate. So if you look at your CO2 multiplied by 95%, that's one indication. If you look at your urinary pH, so a lot of people will say urine pH doesn't reflect what's going on in the body. So what happens is remember I told you how like the liver oxidizes the sulfur-containing amino acids to sulfuric acid, and
Right.
that gives hydrogen ions. It's the hydrogen ions which acidify the body. Those get mostly handled by our bicarbonate right away. So right away, our bicarbonate gets depleted. So our kidneys are going to want to make up that bicarbonate. In order to do that, though, they have to produce an equal amount of acid. So the acid in the kidneys is directly reflective of how much acid depleted your bicarbonate because the kidneys will produce that bicarbonate again, but they have to produce that acid, the same amount that was released from the liver that originally depleted it. So it's actually the kidneys forming and secreting the acid in our urine, and that is directly reflective of the hydrogen ions that were released from the liver. So it does tell you to a very decent degree of the amount of acid that has been secreted over the last 4 hours, essentially. So if you have an acidic urine, you 100% have released an acidic amount of hydrogen ions that can acidify the interstitial fluid, leading to osteoclast activation and bone breakdown.
That's okay. So what is the range you want to see in an individual?
Ideally, you want a urinary pH. You don't want to be secreting any acid, ideally. So you want a neutral urinary pH, or even alkaline is fine, to an extent. Personally, I'm okay with the 7 to an 8 as a pH.
Oh,
As you go below 7, you are now secreting some hydrogen ions, so which means that you are having some of an acid load in the body. Ideally, you don't want any. I would say you have a clinically meaningful acidosis if you have a urinary pH of 6 or less, to the extent that you are now releasing so many hydrogen ions. 50% of the population will be retaining some from the limited capacity of the kidney's ability to get rid of them. So we also need to think about this as a time perspective. The kidneys don't have enough time, if you're eating every 4 hours and releasing all these hydrogen ions, to ramp up ammonium and get rid of all the hydrogen ions. It will start building up. So you got to think about this in real time, like what is really happening in the real world. And so that's why a lot of people don't believe in low-grade acidosis as well, because they don't understand the limited capacity of the kidney's ability to get rid of hydrogen ions. And balance studies back in the 60s have shown, from Lemon and Lennon group, that somewhere between, when you are at a urinary pH of somewhere between 6 and 6.5, half the population will be retaining some of those hydrogen ions. It's just too much for the kidney to actually excrete. So that's another good way to check if you have low-grade acidosis, is if you have a urinary pH of 6 or less, you definitely have a fairly, I would say, high level degree of low-grade acidosis.
that's fasting. So if you do it your lab work in the morning, you should expect a
I
7.
wouldn't, no, I wouldn't do it fasting, because fasting will typically be a little bit more acidic than non. And you don't want to do it too quick after eating a meal either, because there's something called the alkaline tide. Remember, I told you how the body in the kidneys will secrete bicarbonate to get back what was lost, and it has to produce an equal amount of acid, and then it just excretes that acid, and it reabsorbs the bicarb.
Yep.
Same thing happens in the stomach. So in the stomach, when you essentially secrete acid, you reabsorb, or you form bicarbonate and reabsorb it. So when you're eating a meal, you've secreted the acid to digest all the food, but you've also produced an equal amount of bicarbonate. So your urine will actually look more alkaline. It's called the alkaline tide after eating. until because it takes longer for the proteins to digest in the stomach and the amino acids to reach the liver for then the liver to release the hydrogen ions. So you've absorbed more bicarbonate at first, appearing alkaline,
Okay.
but an hour or two later, all of a sudden, all these hydrogen ions are going to start releasing. So you never want to do a urinary pH in the morning because you'll be more acidic than it's just more of an acidic state. So that's not a good way of testing it. 3 to 4 hours after you eat a meal, that's when you want to test your urinary
The
pH.
urinary strip also,
Yeah, yeah.
right?
Vivu is one company
Yeah,
that does
I
a
use
urinary strip, but there's others. Test it 3 or 4 hours after you eat, and that's a decent indication too of low-grade acidosis.
okay. Uh, so you touch on a good point. So because this is now a specific time frame, we're talking 3, 4 hours after a meal. So what
Mhm.
happens if you have a pattern? Let's say, and we can we'll touch it a bit later on about you doing the so-called honey diet, which is now pretty popular. So you're eating a lot of carbs or fruit, for example, most of the morning, and in the evening you eat more a carnivore type of meal. So, you know, so what happens? And you measure your urinary pH 3, 4 hours after, in the evening after your carnivore type meal. Uh, what would you expect to see there?
Yeah, if I would, so I would expect to see because you ate a carnivore meal, there would be a lower pH. It would be less than 7.
So you still then, your recommendation would be that you have a balanced meal, which includes, well, your meat, but also the alkaline source of food.
Yeah, so you can there's a few ways to go about it. Some carnivores do just not, for some reason, whether it's true or not, they claim that they don't tolerate any plant foods. So if you don't tolerate avocados, fine, right? You don't tolerate potatoes, then just take the bicarb supplement. That'll offset the acidosis. However, I think there's a lot of benefits eating things like avocados, which are bringing boron, which you're not getting much of on a carnivore diet, which is bringing magnesium, which you don't get a lot of on a carnivore diet. It's upping your potassium intake as well. Eating just muscle meat isn't going to get you a ton of potassium. You'll get enough just to remain in positive balance. You might get 2 grams of potassium, but that's
Mhm.
not an optimal amount. So if you start adding avocados, you can get up to the 3 or 4 grams, which is a more optimal amount. So if you can, ideally, having like half an avocado to a full avocado will help offset the acid load a little bit. You need to consume 2 to 3 times technically in weight the amount of plant foods as animal foods to fully offset the acid load. And of course, it'll depend on the plant food and it'll depend on the animal food because different animal foods are more acidic than others and different plant foods are more alkaline or will bring more alkalinity to the body than others. So oxalates prevent the release of the alkaline minerals, the citrates. So you don't want to be consuming any high oxalate fruits or vegetables because it won't contribute to the alkalinity in the body as much.
Okay. So let's summarize before we move on. So maybe you can confirm my understanding. So first of all, we want to balance our diet, acid load with alkaline foods, and the best way to do it is measure our BUN, our albumin in urine, our pH in the urine, our GFR, which is a good indicator of our kidney function, um, and all this depending on our, but still wanting to use protein as for structure, not as energy, and that is probably around 1 to 2 grams of kilo, depending on the person. If he has more muscle mass, he can go a lot higher, up to 2. But I guess that he needs to eat more calories, or he will eat more calories. Did I miss
Yeah,
something?
you would also want to add cystatin C to kidney function because GFR obviously, creatinine, et cetera, that's not perfect. So do cystatin C. Make sure your cystatin C isn't trending in a negative way for measuring kidney function. Look at urinary calcium. So basically, typically, the calcium in your urine over 24 hours should be about 16-17% of your dietary intake. A lot of carnivores will have a high calcium in the urine, even though they're consuming a little bit of calcium. that is indicative of bone breakdown and extra calcium coming out in the urine due to the acidic state in the interstitial fluid, but also because an acidic urine reduces the reabsorption of calcium too. And so you lose more in the urine. So check also, if you can, check bone markers of bone breakdown and bone building. You can check urinary and serum C and N telepeptides. Those are basically markers of collagen in bone. So you can see if those are increased, if you're breaking more bone down, and you can test osteocalcin, which is a marker of bone building. So that'll give you a little bit of a hint is, am I over breaking down bone? And look at the urinary calcium and see if that's elevated, which it typically is on a carnivore diet. Yes, balance is important. A lot of people say, don't believe in the alkalinity thing. And here's kind of how I like to approach it. Did you know that your blood is a pH of 7.4? Most people say, oh, yeah, well, that is alkaline. And they don't even realize how alkaline that actually is at a temperature of 98.6. Because at a temperature of 98.6, the pH of water is 6.8. It's only neutral or 7 at a temperature of 77 Fahrenheit. But as temperature increases, that affects pH. So when you consume a fresh animal, you are consuming an alkaline animal. It's got a pH of 7.4. It's high in bicarbonate. So people that don't want to believe in alkalinity, well, that means you don't believe that your blood pH is alkaline, because if you consumed an animal, it's literally alkaline until post-mortem anaerobic metabolism kicks in, where, blood flow starts shutting down, you start breaking down glycogen, and you start releasing lactate, and you start acidifying the fluids, right?
Mm-hmm.
By the way, that doesn't happen in the cold of the Arctic, though. At minus 18 Celsius, that amount of cold completely shuts down glycolysis and glycogen breakdown. So the Inuit could get a lot more glycogen, and they would have a less acidic food if they were consuming it at cold temperatures, which they were, because the Arctic was an icebox and could easily get down to minus 18 Celsius. But also they would consume diving marine mammals, which, because they can die for hours without oxygen. After a marine mammal dies, like a whale, they were eating walruses, right? These diving marine mammals, they actually don't undergo glycolysis for 24 hours because they're so high in anserine and beta alanine, it prevents basically the acidity and the anaerobic metabolism. So a lot of people, what I'm trying to say is a lot of people use the Inuit as an excuse. The whales would store a lot more glycogen than normal. They had a lot more glycoproteins in their skin and also in their intestine, and they wouldn't even break down their glycogen for 24 hours. And then the cold would also prevent or slow the glycogen breakdown. So Inuit were getting a lot more carbs as glycogen, as glycoproteins, and they also would consume the plant contents of the stomachs. They actually cherished those the most, even more than protein and fat, as per several doctors that lived with the Inuit for over 20 years. So they would pass around the moss and the plant material of the animal stomachs like appetizers. They cherished them. And they didn't eat a high-fat diet. They had to use the fat. Again, they're living in an icebox. They had to use the blubber to heat where they lived. So they used it primarily as heat. And they needed it for light, otherwise they couldn't see. So the blubber was mostly used for lighting and heat. They ate a tremendous high amount of protein, about 250 to 300 grams of protein, animal protein per day. And that's probably why their females developed osteoporosis by the time they were 60. They had much less bone mineral density than Inuit compared to age-matched Caucasians. And extinct Inuit, they showed a lot of compression vertebral fractures as well. So basically, what I'm trying to say is, like, all this stuff is super nuanced. And then the main argument too is a lot of people say, how come carnivores are so healthy though? How come these issues aren't showing up? Well, for one, I didn't do well on carnivore. I had low energy, exercise intolerance, cold extremities. I stopped. Carnivore MD stopped. Carnivore Aurelia stopped. Many people have stopped carnivore, and many people have had issues. Like, I have several screenshots of someone who was carnivore keto for 10 years. 18 months ago, they upped their animal protein intake and they developed calcium oxalate kidney stones. I have other screenshots too from people who had a CO2 of 21, which is a bicarb below 20. So very bad low-grade acidosis. And they were having muscle cramps, heart arrhythmias, etc. So to say that we don't see these clinical symptoms, I think is false. I think that's not true. And I think that's unfair to say. And also, I've had several individuals say they've tried that they were on a mostly carnivore diet or carnivore diet, and after taking bicarbonate supplements or bicarbonate mineral waters, their gout completely went away. Their joint pain completely went away. I have those screenshots. I've shared them on Twitter. So I don't think we should ignore those either. I'm not saying everybody will develop issues, but I do think that it's just not optimal to eat muscle meat. It just, there's not enough calcium in muscle meat either.
Something came to my mind that I've heard in one of the rapid discussions that one guy was saying that glycogen to protein in fresh meat has a ratio of 1 to 1. Have you come, do you know any ratios? Is this correct, or it sounded a bit too much, to be honest, but I'm not
Yeah,
sure.
no. So typically, I think in muscle it's more like 0.1 to 0.2%, and I think in liver it's like 1 to 2% of total weight is glycogen. So like a full-grown whale could give you like over 1,000 pounds of glycogen, but that's in like, like a 50-ton whale.
Yeah, okay.
Um, but if you think about like liver glycogen, we have like what, like 100 to 120 grams, and in muscle it's obviously more than that. Um,
So, okay, so it's 500 grams in a human being, overweight of 60 kilos or whatever. So it's okay,
Got it.
it's the same. Okay.
Urea is osmotically active and pulls water with it, and the hyperfiltration can increase dehydration. So when you eat a high animal protein diet, a lot of people suffer from a lot of urination in the daytime and at nighttime,
Hmm.
and urinary urgency. And taking 4 grams of sodium bicarbonate twice a day in 2 clinical studies has been shown to significantly decrease daytime and nighttime urinations, urinary urgency, and those with a urinary pH of less than 6. So there's another harm of carnivore essentially, because your urinary pH is going to be less than 6. Mine's always like 5 when I'm eating a high animal protein diet. So, and I was suffering a lot from urinary, a lot of was getting up 2 3 times at night, and sodium bicarbonate balancing that acid can help with that. So
Hmm. So
it's
that's
just
one concern, right?
yeah,
Okay.
something we should cover, because a lot of people say I don't see the harms. That's one thing, and we should cover the sodium bicarbonate benefit studies, which show benefits on kidney function and bone health very quickly, and we can go over those. Um, so how much protein? Good question. In the Bellevue study, when Anderson and Stephenson started going too high protein, they started having a lot of diarrhea. So you really shouldn't go over a total of 40% of your total calories as protein, because then you can, like rapid starvation, etc. That will start happening. You
Hmm.
basically start getting a lot of diarrhea, and you can start wasting, almost like wasting away in a sense, because you're not absorbing your nutrients well. So 40% is about the limit of protein that the body can technically handle. So the rest should be essentially fat with some carb. Now, depending on how you tolerate carbs, some people tolerate none. Whereas I personally think for the average person, somewhere around 60 to 120 grams of carbs is probably optimal for most. But that doesn't mean that some people don't benefit completely cutting out carbs.
It's just that I mentioned this example of depending on gluconeogenesis because at the end you depend on glucose, right? So you're running on glucose. So you probably be okay. Well, you might have some ketones, so zero point 0.3. I've seen Sean Baker reporting this, but at the end you're mostly depending on uh, glucose on your primary fuel, not on fat, even if you're not eating any carbs, right? So you think that's normal, or you have any concerns on that?
It's a good question. I think it's interesting that the body wants to turn excess protein into glucose and shut down ketones. If ketosis was the preferred fuel, why would it want to take extra protein and make glucose? Um, so that's one thing. The other thing is, yes, bison, venison, deer, like the animals that were available to like the Plains Indians are very lean. Like there is fat, and they would cherish the fat, of course. But when you look at the comparison between like even a grain-fed cattle versus a grass-fed cow, it has over twice the total fat. in muscle meat compared to a grass, and then comparing a grass-fed cow to like wild animals that would have been available to us it's even fattier than the wild animal. So the muscle meat of bison, of deer is very lean. So yeah, we definitely would have consumed a lot of lean meat, but we of course would have also eaten the visceral fat too.
Sure.
Um, but how much visceral fat would there be to share from a huge tribe comparatively to all the lean muscle meat? There's obviously way more lean muscle meat than there is visceral fat in an entire bison or deer, right? Like that's
Mhm.
kind of obvious. So how high of a fat intake was it? Obviously, would depend on geographical regions and what's available to you. But yeah, I believe that ketosis, whether it was more only happening at periods where people weren't eating, um, it, it hard to say. Like I hate to even
Okay.
speculate, right? You know what I mean? Like I hate to. I just personally don't believe that chronic ketosis is the ideal functioning because the brain ketosis can only suppress at the very most maybe 85% of glucose needs of the brain. So the brain has to still have some glucose. At minimum 15%. So ketones can't fully suppress it. And then other organs too, in tissues, can't fully run off of like the Cori cycle. Like red blood cells, only 80% can run off the Cori cycle. So 20% still has to come from glucose. And there's many other tissues and organs that cannot fully run off of ketones. So I mean, how I look at it is like for like 20 million years, you had primates primarily eating plants. And then all of a sudden there was not a switch, but a lot more availability and consumption of animal foods in Africa, hunting elephants, but also a lot of availability of fruit in that tropical climate. So like there was never, I don't think, a full switch over where like we went from consuming fruits mostly for 20 million years, right, as like chimpanzees, to then 2 to 4 million years where yes, we're eating a lot more meat now, but the fruits and tubers, et cetera, are still available. I still think the body's is primarily wants to run on glucose, not ketones.
Okay.
That's just my opinion.
Cool. Appreciate it. Okay, let's continue on the dangers of protein because we drifted a bit away. So, you wanted to discuss a few more things. I have noted here. What about one point which is I think quite important, the amino acid balance. So, do we want to balance glycine with methionine? What are the dangers of methionine, of high methionine? Animal protein has more methionine from, I don't know, beans and lentils, etc. Do we want to, how do we structure our protein intake with regards to amino acids?
Yeah, so basically, any mammal over 88 pounds does not synthesize enough glycine for optimal collagen synthesis.
Mhm.
So basically, I try to hit around 10 grams of glycine per day, whether it's half from collagen, which is typically what I do. I try to get 20 to 30 grams of collagen. Usually I do 10 grams 3 times a day. As you go over 10 grams, you will start increasing oxalates in the urine. So try not to go over 20 grams in one sitting. But if you can space it out, you can get away with a lot more collagen and not have as big of an issue in regards to increasing oxalates in the urine, et cetera. Um, so I try to consume about 30 grams of collagen per day. I think that's probably a pretty optimal intake, which would give you 6 grams of glycine. It's
Okay.
basically 20% by weight glycine. And then I'll take like an extra 4 grams of just pure glycine in addition to that to try to get to 10 because most humans lack about 8 to 10 for optimal protein synthesis. And basically, we found that taking glycine gives you the same benefit as methionine restriction without the negatives of methionine restriction. So you don't have to restrict protein per
Okay.
se to get the benefits. You can just supplement with glycine.
So we are not afraid per se of methionine. We just want to balance it with glycine.
Exactly.
I
And
think also this balance is in various studies as one of the longevity let's say, markers which we want to be aware of. Okay, so back to the danger. So did you want to cover something more? But you
Yeah,
mentioned.
the only thing is there's a few studies too that basically that fiber, and I really I'm not a huge fan of fiber there are, but I think that there's still a little bit of a debate in this field whether fiber can offset some of the harms of basically potential colon cancer, right? Uh, obviously you don't want to eat the charred meat, processed meat, those probably definitively can increase the risk of colon cancer. To cut off the char, don't eat processed meats,
Hmm.
or minimize them. And then whether red meat or not, I think regardless, I think an avocado, that extra fiber may help offset some of it's called like putrefaction thing, like the substances that happen when the body's metabolizing meat. There's been a few studies in humans showing increased markers of potential that aren't necessarily great for colon cancer. We still need more research, and I'm not saying meat causes cancer, but I think it's interesting. I still think there's enough data where it makes a ton of sense to pair meat with an avocado. Even there's been a couple studies looking at burger consumption with or without an avocado, and the oxidative stress is much less when you consume a burger with like olive oil or with avocado, etc. So I think again, balance balance actually is important. People think it's not, but methionine is acidic because it turns to cysteine and releases hydrogen ions. So a high methionine diet without the alkalinity can be bad. A high methionine without a lot of glycine can be bad. So there is a balance because our bodies aren't perfect at handling just, high amounts of amino acids. Just like you can overconsume carbs or fat, people, it's crazy to think that we can't overconsume protein and that there's not going to be any harms, that somehow protein is exempt from an overconsumption type of issue. It's not.
Also, I'm trying to educate at least my clients on this because they tend to think that okay, if we start keto, then more keto is better. In that case, I think we should not just think more is better, but we need to find that optimal space in the U-shaped curve, and then we're good. Also, what's your opinion on stress? So I didn't want to cover this. I didn't have this in the agenda, but I mean, are you of the belief that yeah, too much or a carnivore diet would be stress inducing, so trigger glucocorticoids and adrenaline and cortisol and all these things. So do you have an opinion on that?
So there's arguments for and against this, right? Yes, cortisol increases. Yes, noradrenaline increases to increase gluconeogenesis. Whether the normalization after 4 weeks is true normalization or if that's like adrenal burnout, I think depends. I kind of felt like I had sort of burned out after a year on carnivore. Paul Saladino kind of felt the same way. I think it depends on the person. I think some people can handle that stress, and some people can't. I think it just depends on the person. So, because to me, the hormonal changes directly reflect what happens in starvation, right? Cortisol going up, noradrenaline going up for weeks. To me, that's a stress response. Okay. A lot of people in the carnivore keto space will say, but it normalizes. So it's not.
Mm-hmm.
Well, okay. Same thing happens with low salt, right? So renin goes up, angiotensin 2 goes up, aldosterone goes up when you're on a low salt diet, but eventually it seems to trend down lower. But in the animal studies, what ends up happening is the adrenals hypertrophy on a low salt diet, and eventually hypertrophy leads to burnout. So, like, is the adaptation, is the reduction due to a burnout or is it due to a true normalization? I think it depends on the person.
Okay, so you need to listen to your body and how you react.
Yeah.
Because I think especially you need to listen to your body when you're exercising a lot and see if you're really improving and if you have the energy, right?
I think it's for a lot of people, it's the addition of exercise to keto that after a long time, is very stressful on the body because in a ketogenic diet, after exercise, cortisol is much higher. And I don't even know if that actually normalizes. So it may normalize at baseline, fasting levels. But after exercise, I don't know if the enhanced stress, enhanced cortisol, enhanced noradrenaline actually does normalize.
My personal experience is that it did not normalize, and but maybe I was the type of person that was doing maybe too much keto, but too much fasting and too much exercise. So all
Mhm.
together. So these are, I mean, the combination was not perfect, and I had to adjust. And by adding more calories, I added a third meal instead of doing 2 meals a day. Slowly added some carbs. So yeah, again, you need to listen to your body. I think that's
And
important.
that's a good point, right? Like I don't want to just blame uh the ketogenic diet. Maybe it's you're not getting enough calories. Maybe you're overdoing exercise too, but it increases the propensity to burn out versus having some more carbs. That's the key. Everything's on a graded scale, right? Like eating a high animal protein diet may not cause gout or kidney stones in a lot of people, but in someone that's not drinking a lot of water now, you're bumping them up and increasing the risk, the propensity to actually get a kidney stone then. So everything becomes additive. And so that's why these things, just because they're not shown broadly, doesn't mean that it's optimal, nor that other things will happen 10 years down the road, like you're more dehydrated or you're over exercising, and all of a sudden it's throwing you into that issue. Whereas if you would just eat a little bit more carbs, that wouldn't have happened.
Exactly. So with everything, I think you don't want to go too far down the line, first of all, because if you're in a stress state, let's call it like that generically, and you're too long, then maybe it takes also a long time to come back. Whereas if you never went into that stress state, then you're in a happy place and you're performing well. Okay, so next topic is about protein metabolism and insulin resistance, which is a hot topic from my perspective and something I'm very interested to hear your opinion. Um, and I'll just give some headlines and then we can discuss. So first of all, we know, I think that's a kind of a probably fact, and in any case, many people talk about it, that insulin resistant people have high BCAs in serum. Here we have also a lot of studies that say that we would benefit from less protein. For example, just mention one title where it says dietary protein restriction improves metabolic dysfunction in patients with metabolic syndrome, etc., etc. So you're obviously a believer of protein as a satiety factor will help us lose weight. Uh, so that's, I guess, probably true because we eat less calories. Maybe you can explain that. But what's your opinion on protein restriction? So two questions. So why do you support protein, or I guess protein within the normal range for weight loss? And what's your opinion on protein restriction in that context for people with metabolic syndrome?
I think there's another debate too, and we don't have full clarity on it yet, that a lot of people going on carnivore or keto, their fasting glucose keeps trending up.
Mm-hmm.
Uh, and I don't think anyone truly knows why. Whether we're trying to keep glucose higher because less is available, but there's also the possibility, which has been proven, like if you induce mild metabolic acidosis, that can lead to insulin resistance, which can be improved by bicarbonate. So it's also possible is are you actually acidifying the interstitial fluid, inhibiting the insulin receptor, and actually more insulin resistant because of that? That's a possibility. And that's been shown in several studies. Actually, if you cause low grade acidosis, it does induce insulin resistance, which can be fixed by alkalinizing the body, taking alkaline supplements too. So there's that piece as well. Is if you're over consuming high animal protein, so we got to understand that the receptors interface the interstitial fluid, and they only function well at a very narrow range of pH. And same with enzymes. So if you start messing with the pH by over consuming animal protein, you can start messing with those thyroid receptors, insulin receptors. So I think some of that could be going on too. Um, so I
Okay.
think we need to know more because we don't have true proof. And it's almost like, how do you prove that? I haven't even thought about that deeply enough, to be fair.
So I never thought about that approach. So basically, what you're saying is, okay, we have a metabolically dysfunction person with maybe, or even not metabolically dysfunction, just a person with higher blood glucose levels, and that can be not because he eats more protein, but because his body is more acidic, which then has an effect on the insulin receptors.
Well, it would be due to the high animal protein intake causing the acidity. Yes,
Okay,
which
but
can then
he could, I mean, he could, maybe he's not balancing it out, right? So,
correct. Right.
okay.
Certainly a possibility. Yes.
So, um, so in that, if you were to suggest someone to a diet for weight loss, so would it be a high protein diet, a lower protein diet?
Yeah, for weight loss, I would say certainly an adequate protein diet, but yeah, just simply offset with either bicarbonate or citrate supplements if they're unwilling to consume things like avocados and potatoes, or consume some of those foods as well. But typically, you're not going to consume enough to fully offset the acid load. Like I said, like most people
Mhm.
aren't consuming 2 to 3 times in weight the avocados compared to their animal foods. So most people are still going to need some bicarbonate or citrate if they want to fully neutralize the acid load.
Okay. You kind of did not answer, so I'll kind of insist. So you don't really care about protein restriction in that sense.
No, I don't. I don't think protein restriction um, on a low carb intake. Like if you're eating a lot of carbs and you start eating high protein, maybe that might induce more insulin resistance versus like on a low carb intake. Um, and so in someone that's like a carnivore or keto, I don't think there's necessarily a reason to be on a low protein intake from like a longevity perspective. I don't think that will really pan out the animal studies and the rodent studies versus humans, because I do believe that we were fairly hyper carnivore. And so I think also from a weight loss perspective too, it doesn't seem like low protein. I just don't see overall a benefit of low protein over high protein because you can simply you it doesn't fully offset all the harms, but bicarbonate or alkaline foods does offset a majority, in my opinion, of the harms, and you get to reap all the benefits of eating a good amount of protein.
Okay. But you said an important word, longevity. So we have okay, many studies and many people suggesting that fasting is the or calorie restriction in this case. They kind of equate it, although I don't think it's similar, that they lead at least in mice to longevity, maybe because of reduced mTOR, maybe because of protein restriction, or all these things connected in some way. Is protein restriction in that case longevity? So I'm not talking about, of course, um, life quality, right? So I think we need muscle in order to have a proper life quality. But when we're talking about longevity, I'm not sure. Disregarding quality, I'm not sure. But maybe reducing the risk of cancer, etc., or of excessive mTOR activation. What have you seen in terms of research with regards to protein in that case?
Yeah. Um, it's a tough one. I don't think that the animal studies showing longevity will pan out for humans on severe protein restriction. Um, and it just depends, right? Because not having enough, if you restrict protein and you start losing muscle, and that could lead to a fall, and you break your
Yeah.
hip or your bone. Right? Protein. The thing is protein actually is also very important for bone health. So, like, if you're only getting zero point 0.8 grams of protein per kilogram, that's really not enough for optimal bone health. Like, and so what are we defining as protein restriction, right? Like if it's 1.4, maybe that would be better from a longevity perspective versus like 2.2. Maybe we're all completely speculating, but if you're talking about protein restriction from like a 0.8 gram per kilogram, I don't think that's good at all because I think that's going to suppress bone health, muscle health. But maybe trying to lower it from very high intakes to a more moderate range may be good. But just from my perspective, like I probably eat 150 to 200 grams of protein per day, and I feel good at that level. But that's probably I weigh 163 pounds, so that's like 74 kilograms. So I'm at to 2 point something. So I feel good at that level. So I
With
would
how
rather
many
live good
calories,
and
if I
do
may ask? So
how many?
how many calories?
I'm probably about 2,200 calories, 2,300. Like
Okay.
that's like my maintenance calories. Um, and I'm probably getting like 150 to somewhere to 200 grams. So I'm probably over 2 grams per kilogram on protein intake because I just offset the acid load with some avocados, some potatoes, and bicarbonate capsules. So that's where I feel good. Like I would prefer, since we don't know, I'd rather have the leanness, the feeling good, building good muscle, and I'll worry about if I die 10 years earlier down the road.
Okay. Yeah, that's a good approach as well. So you mentioned supplements. So we did not summarize, maybe for our listeners, what is your suggested protocol when it comes to bicarbonate, balancing acid with alkaline elements. So what do you suggest?
So I've tried. Um, I first started with Gerald Steiner water. That was probably back in 2017. Worked really well for a while, but it's very, very carbonated. And so it was really bloating my system, and eventually it was causing some reflux issues for me.
Mhm.
So I switched off of that and went to citrate. I was consuming sodium citrate. I did that for probably mm, a year or two, and then citrate. If you don't take it with enough carbohydrates, it does hurt your stomach and intestines. So I've been on now a mixture of sodium and potassium bicarbonate for probably about a year now, and I have had no issues. So that to me, that's like the perfect balance because you want to balance sodium and potassium. I think if you're only consuming sodium bicarbonate, you're not going to get the maximum benefits by taking a combination. So I take it's called bicarb formula. It's just a capsule on my full script. And basically, I take about 3 capsules of those with every 7 ounces of animal foods.
Okay. So together with your meal, basically.
Yeah, because if you don't, if you aren't increasing the bicarb level as the hydrogen ions are increasing, like you're taking, let's say you take your alkaline supplement 4 hours after you eat an animal-based meal. Well, it's the acid load's already been released. It's already gone into the capillaries. It's already acidified the interstitial fluid, and it's already activated osteoclasts to break down the bone. You've missed your window. So you really do need to consume alkaline supplements, and there's been studies proving this pretty much within 1 hour, either before or after you ingest animal foods, so that the bicarb spikes while the hydrogen ions are being released in the bloodstream.
Okay. Would be good, maybe afterwards you can send me those studies because
Yeah.
I'll link to them. Okay, good. How do we also balance protein for muscle protein synthesis? But maybe let's start. What is your exercise regime or protocol at the moment? So how much and what type of strength building are you doing?
So I play basketball almost every day, 20 to 30 minutes. So that's your high intensity interval. I also sprint, especially now that it's the summer, probably 3 times a week. So I'll do like 200 to 400, so fairly long meter sprints, probably 5 of those. And then I also lift weights probably 4 days a week, maybe five, depending, 4 to 5 days a week. And I lift fairly heavy, not super, super heavy, but I lift fairly heavy.
So you're going with I don't know, 3 to 5 reps or 10 reps?
Uh, what I typically do is somewhere between, uh, I don't lift as heavy as I used to because I tore my pectoralis tendon when I was 26, which kind of got me on the importance of collagen. because most injuries are from your tendons and ligaments, actually,
Mhm.
which I was never consuming any collagen, and it's still torn. I never got it surgically fixed, so I can't really lift heavy on anything to do with chest or especially incline chest. Um, but I typically, but like bicep, tricep, I can go pretty heavy. Back, I can go pretty heavy. So it depends on the muscle group, is what I'm trying to say. Like if I'm doing chest, um, probably 10 reps.
Okay.
Um, and if I'm doing like bicep, I can get away with like maybe six, where the last 1 to 2 is difficult. You typically don't want to go to failure because all that's doing is increasing your chance of injury, increasing the time it will take you to recover, and there's no added benefit. So if you stop at where you still have like 1 rep left in you, you get all the benefits and none of the harms of trying to go to failure.
Yeah. Yeah. I think I have a similar protocol. First of all, I'm also a fan of basketball, so maybe I don't know if we meet, we shoot some hoops. Um, yeah, at the moment I'm training 3 times a day, strength training, I mean. Um, yeah, but for me, the most important from everything of what you said is overall recovery. So to be able to train 3 times a week or whatever one decides, because if you go too far or too many sets or too many sets to failure, etc., then it's difficult to recover. Or I mean, maybe you recover, but you're not doing anything else the rest of the day because you're so exhausted. So I think that's maybe something people should think about. But how important then is recovery and protein to your strength protocol or overall exercise protocol, I would say.
Yeah, very, very important. Both protein and actually alkalinity is important for recovery. So you can take, like, if you're going to be doing high intensity and you're going to be producing a lot of hydrogen ions and increasing the acidity in the body, which happens when you do vigorous activity, somewhere like 4 to 6 grams of a mixture of sodium slash potassium bicarbonate, like 90 minutes before that activity can really help not only increase your performance, but decrease delayed onset muscle soreness. Because part of that muscle soreness is contributed due to the acid load of anaerobic exercise. So, another benefit of taking bicarbonate is what I'm trying to get at is improved exercise performance and recovery. Also, improved muscle protein synthesis because the acid load, you have to break down glutamine in muscle in order to form ammonium to help excrete more acid and also the negatively charged sulfate. So you will get improved muscle protein synthesis. Not that you can't build muscle on a carnivore diet without bicarbonate. You can. You'll get improved muscle protein synthesis though if you offset the acid load. So that's another benefit. And then if you look at so a lot of carnivores will be like, well, how do we know bicarbonate is beneficial? If you look at people with kidney dysfunction or low bone mass or osteopenia or even elderly women, you give them bicarbonate or citrate and their bone mass dramatically improves and it happens quickly. And there's many randomized studies proving this. So like alkalinizing the body has many benefits on bone health, on kidney health, and again, on urinary frequency and also athletic performance. And then, of course, protein. If you take, a lot of people are dosing their essential amino acids incorrect. If you take it pre exercise, that will help decrease delayed onset muscle soreness. And you want to take creatine post exercise with carbs and protein because the insulin spike from the carbs helps drives creatine in and post-exercise muscle takes up creatine better. So a lot of people are doing it wrong. They're taking creatine pre-exercise when it should be post, which 2 studies have shown post-exercise is better than pre-exercise creatine in regards to more muscle strength, better lean mass gain with creatine post-exercise, and they're taking amino acids wrong. They're taking their essential amino acids after exercise when they should be doing it pre to help decrease delayed onset muscle soreness.
Basically, what you're saying, we should not train fasted, right? So we should maybe get some amino acids like in a shake type of thing before we exercise.
I think from a like if you want to decrease delayed onset muscle soreness, and if you want to, because you can still take the protein afterwards. So muscle protein synthesis isn't the benefit. The benefit is decreasing delayed onset muscle soreness. I always run though fasted typically But if you give yourself enough time and get the amino acids out of your stomach, so basically taking them 60 minutes prior or 45 minutes, I wouldn't consume it like 30 minutes before because that could still be in your stomach and affect, cause cramping and bloating, etc. If you consume it early enough, 45 minutes, I would say before, then you may help decrease delayed onset muscle soreness.
Okay. I don't have anything else to cover. I think we talked about a lot of things. What are you doing at the moment? So what are you working on? Any special projects you're doing?
Hmm. Yeah, I mean, so if I were to do another book, it probably would be on the acidosis topic. I'm not directly working on one right now, but I think there's enough with so much nuance between the bicarbonate in fresh meat versus not, the Inuit and the glycogen they used to get versus carnivore, which doesn't. I think there's so many cool things that people could learn. And I think there's a lot of benefits. And I think there's a book to optimizing the carnivore diet. So if I were to do something like that, I think that would be my next project.
Okay, I can't wait. I think you're adding a lot to the community, and these discussions, even if people agree or don't agree, need to happen, because that's the only way we can grow our understanding through, I hope, healthy debating.
Yeah, I would say like in closing, like it's sad, like, I've kind of in a way lost a lot of friends. Eh, I mean, Sean Baker had me on twice, and I still consider me friendly with him. But like, you do start pushing away people like Ken Berry or like, Anthony Chafee. Like I messaged him. He saw the message and didn't want to do an interview with me. But Richard Smith, who me and him have actually debated before, like, and he's willing to have me on. So it's just some people are very dogmatic and don't want to be challenged at all, and you're going to lose those people as friends. And some people are willing to listen to you, and you're gonna have to take a lot of punches. I've had to take a lot of beatings and a lot of insults because a lot of people just don't understand this topic. I've been publishing on low-grade acidosis for over half a decade, and so it's been difficult for me. But I don't. All I care about, honestly, is what's the healthiest diet. And if I have to lose friends over that, so be it. I just want to continue to learn. And I think it's kind of boring to just constantly be in the, okay, just keep your carbs low and that's all you need to know. I want to keep learning. And so really that's what drives me. And it's just, if you feel the same way, you should do it even if you're scared to lose your community, because that's the thing. Like I started out in the low carb community, and essentially I've almost somewhat ostracized myself, except for the people that are willing to continue to learn. So you just got to be willing to break free from some of your groups or have a lot of people challenge you if you want to continue to learn. That's kind of where I would like to leave it.
Yeah, thanks for the advice. And I see it actually as well for me, because it's not only about personally wanting to learn, but also personally wanting to learn in order to be able to help people. Because we should not disregard experiences, right? So if someone is facing something, that means that he's not just an anecdote, right? It's probably a real use case, and we want to discuss it. We want to be able to address it, because
It's exactly. It's just another tool in your toolbox, right? Like now you can, if someone has gout on carnivore, or they're having kidney stones, or they're peeing all the time, or have a lot of muscle soreness, you have a nice tool now in your toolbox. You can go to bicarbonate, or you can go to avocados, potatoes, whatever, and you can help a lot more people by knowing more of these things than just the same old low carb ketogenic diet and that's all you pitch every day. It's like there's no depth to you, right? Like where's the depth? So I like to know a lot about a lot.
thank you. Keep learning and keep educating us as well, James. Uh,
Thanks, man.
it was a great chat. Many thanks for that. And we keep in touch. And yeah, hope to see you again very soon.
Awesome. Thanks, Panna.
Thank you very much.